Okay, chapter 3, day 1 video. What we're going to do is we're going to look at a test for independence with our data that we've been working with. Let's formally define independence though. Independence is when two variables are not related. So there is no association between them. So if two variables are not related and there's no association between them, we would say that they are independent. So we test it mathematically. So here's what we do. Our test for independence, okay? Our test for independence, we use probability. And what we ask is that, is the probability of event A, whatever that may be, is it the same as the probability of event A? And then this little line to us means given event B has happened, okay? We do a lot more with probability later on in the year. For right now, we're just going to look at information in a table, but let me explain what this says. So this is the probability of event A happening. Which is also the same as the proportion of A. If you read it from the table, you can just read off the proportion of event A. Okay? Now, when we set this up, whatever is here and here must be the same letter. This must be the same. Has to be the same letter. Okay? So, this whole thing is the probability of event A given event B has happened. So according to like what we just did today in class, it is the proportion of A that is in group B. Like, what is the proportion of blue-eyed people among the females? Okay? So, we test this mathematically, and you're going to see it's as confusing as this look. It gets easier, don't worry, okay? But if these fractions that you get are equal, then they are said to be independent. If they're equal, they're independent, there's no association. If they are not equal, then they are not independent, and then we would say that there is an association. If they're not independent from each other, then they must be associated. So not equal, not independent. Equal, independent. So our question, is gender independent from eye color? Okay? Is gender independent from eye color? So again, here was kind of today's table. Every class was different. Here's a set of data for one of the classes. All right? So we have males and females. We have blue eyes, green eyes, brown eyes, hazel eyes. All right? Is gender independent from eye color? So you get to pick whatever gender and eye color you want. I'm going to pick females. All right? And I'm going to pick blue eyes. So is having blue eyes independent from being a female? We narrow it down a little bit. Okay? So, what do I want to know? is the probability of being a female, or the proportion of females, the same as the proportion of females given they have blue eyes? And I'll use BL there for blue. Given they have blue eyes. All right? If this is true, this is what we want to know. Then it will tell us whether or not they're independent. Proportion of females. Okay, well, females. 14 are female out of 32. Females, 14 out of 32. That's the proportion of females. Females, given that they have blue eyes, okay? Given they have blue eyes, well, out of the blue-eyed people, there are 3 out of 7. And the question is are those equal? All right? Well, 14 out of 32 is about 0.44, and 3 out of 7 is about 0.43. Now, we don't have a large sample size, so if these numbers are close, then we'll consider them to be equal. So since they are close to being equal, we will say yes, they are independent. So again, and that's it. Let's check. What are we doing? We have to check one of the variables, almost like a marginal versus a conditional. Okay? Blue eyes, female. I'll check female, 14 out of 32. Is that the same as female given blue eyes? Female given the fact that I have blue eyes, 3 out of 7. If those fractions are equal to each other, then they're going to be independent. And since they're pretty close to being equal, we'll say yes, they are independent. And that's it. When we come back to class, I'll review this again, and we'll work on problems that deal with independence.